Hello, my name is Chris Howard. This is my week 13 presentation on regulation of sperm maturation in the germinal epithelium. Okay, so all this information was taken from Silverthorne, 8th edition, which is our textbook. So I'm just going to briefly go over the male reproductive system anatomy. Okay, so the male reproductive system generally can be broken down into the internal and external components. The external being the penis and the scrotum. Scrotum are where the testes are housed, which is where sperm production takes place. And the reason the testes are on the outside of the body is actually for temperature regulation. They're about 1 to 3 degrees less than body temperature. So sperm is produced in the testes. It travels through the vas deferens to the seminal vesicles, and they empty or collect into the urethra. The urethra is the passageway for sperm and urine, but not at the same time. The bulbourethra glands secrete fluids through ducts into the urethra, and then the prostate secretes fluid directly to the urethra. The prostate is significant to men in that it is common. It's the most common cancer in men is prostate cancer, and an enlarged prostate can put pressure on the urethra here, which can make it difficult to urinate. Alright, so I'll go over the testicular anatomy in more detail briefly here. Okay, so the Simiafirus Tubules are the site of sperm production. They are long. They are very long, coiled, like tubules, as you can see here. They're coiled up. And then here is a zoomed in image of the tubule here. The basal lamina here separates the tubule from the interstitial or Leydig cells and blood vessels on the outside. The Semiafirus tubules, they join at the head of the epididymis, which then turns into the vas deferens, which empty into the urethra. The tubules contain two cells. They contain the Sertoli cells and the Spermatogenesis. Excuse me if I didn't pronounce that correctly. The Sertoli cells are linked together by tight junctions, which is an additional barrier between the lumen of the tubule and the interstitial fluid outside of the basal lamina. Some of the functions, the Sertoli cells regulate sperm development, and the Leydig cells, they secrete testosterone. Okay, and I'll talk about how sperm is actually produced. So this is a term called spermatogenesis. So sperm production takes place in the Simiafirus Tubules, as I said previously, and the Spermatogenesis cells, or the germ cells, are clustered near the basal end of the tubules here. So they are clustered down here. They undergo mitosis to create mature sperm, and that's shown over here, the process of mitosis. As this process of mitosis is happening, they are moving towards the tube lumen. Towards the lumen, they become spermatids. That's shown here. And then once they're mature, they lose their cytoplasm and they gain a tail, shown here as a spermatozoa. So then they are released into the lumen of the tubules. This entire process can take 64 days, and there's about 200 million produced per day. So once they reach the lumen here, they're not quite yet mature. They're not able to swim through the tubules and through the vas deferens quite yet. They're actually pushed out by other maturing cells behind them, and it takes about 12 days for the full maturation. So the Sertoli cells, their function is to help regulate with sperm development. These cells, they secrete and produce various proteins and hormones. They also secrete growth factors, enzymes that can bind to testosterone or just promote the development of mature sperm. Alright, so I'll just go over some of the hormonal control mechanisms, or the hormonal control mechanism of sperm production, and also really testosterone production as well. So like a lot of hormonal control mechanisms, it begins in the hypothalamus with gonadal releasing hormone and also kisspeptin, which also influence GnRH. So the release of the gonadal releasing hormone stimulates the release of follicle stimulating hormone and luteinizing hormone from the anterior pituitary gland. FSH acts on the Sertoli cells, which produce different enzymes, proteins, and other factors to help produce and develop sperm. The Sertoli cells also release inhibin, which is a hormone that has negative feedback on FSH from the anterior pituitary. So this is just a mechanism to control how much FSH is being released. On the other side, luteinizing hormone goes to the Leydig cells, which produce testosterone. The testosterone acts as negative feedback to the LH and the gonadal releasing hormone. And this is another mechanism to regulate how much of the FSH and LH is being produced, and therefore how much sperm is being developed and how much testosterone is being released into circulation. So I'll continue on hormonal control. This is a graph from one of the homework assignments that I think was or is related to sperm production. So this is a question showing that men were given testosterone, and you can see that here their levels increase, and then because of the testosterone they were given, because of the negative feedback shown here, the gonadotropin-releasing hormone decreased. Therefore, the FSH and LH decreased as well, and you can see that on the graph here. So therefore, their sperm production would also decrease. It says then the men were given FSH. So if they were given FSH, this would increase, FSH would increase, and they would produce more sperm. They would also produce more of the inhibin, but because they would be giving the FSH, it wouldn't affect it much. The anterior pituitary would not be producing the FSH, but they'd be given it. So this negative feedback system wouldn't really be working. So then they were stopped giving the FSH and they were giving the LH. And you can see LH peaks or spikes up there. So then testosterone may increase there because of they're given LH, but if they're already being given testosterone, then it may not. So you can see here how just these mechanisms, how the hormonal control affects sperm production, and how testosterone affects sperm production by the negative feedback control of FSH and LH and gonadotropin-releasing hormone.